is to finish AP practice. Finish? Well, we better get started. So, number 1. You got ln. If you guys remember, I did some sort of picture like this. We did this the other day, so I'm going super fast. We have ln coming up and over. We have x equal to e coming up somewhere to the right. We have a region that's contained within, area that's contained between all of the 3 things they gave me, which was ln, x equals e, and the x-axis. Use those 3 as your boundaries, and that's what I get. Cross sections perpendicular to the x-axis. Hopefully you thought of slice it top minus bottom. Coming up in a square, whether or not you can draw pretty or ugly like me. So we should be able to get, is that a dx or a dy?
Yes.
That thickness is horizontal. We have a dx. How does that volume formula work? I do need s squared in my integral somehow. I need the integral from x bounds. You guys remember where ln hits the x-axis? At 1. Good. And I told us e would be the other cutoff. So we have 1 to e. We need somebody squared with dx. And who is that somebody? Who's the top of that side? ln. And who's the bottom of that side? The other line is y equals 0. So you do ln of x minus 0, which is ln of x. And you guys already plugged and chugged this to your calculator another time. And what did you get?
0.718.
Good. 0.718. Letter B, do you remember what we did on this one? Remember what he looks like? First quadrant bounded by 8 minus x to the 3 halves. I think I gave you guys this one, this one's picture just to help out. But you could also find like intercepts. For instance, you could say, hey, when x is 0, y is 8. Oh, okay. And when y is 0, it's a little bit messier. It would be 8 to the 2/3, which would end up being 2 cubed to the 2/3, or 2 squared, which I think is 4. Did I forget about that? And then we have some sort of parabolic like swoop going down. Swoop. Good bit. Area in between that function, and it said the x-axis and the y-axis, so in this case we got that guy, we got that guy, we got that guy, and that's the area contained between. Where are we revolving it about? Put your little revolution arrow. If you think about your little revolution arrow, what would give that a cylindrical thickness? Dx or dy? Dx is horizontal, so we can say, hey, that's going to be a dx. Since we're spinning, right? Since we're spinning, question, what kind of cross-sectional slices am I going to have? Yeah. I'm going to have discs. Is it flush with the axis, or is there some hollow? It's flush with the axis, so it's solid. So all I have to think about is, for every card number 48, v is equal to the integral from 0 to 4. You think about the pi being inside or outside. I need pi r squared with a dx. My radius is going to be, remember, think about from the axis of symmetry, go out towards the area. From the axis of symmetry, pick an arbitrary point, go out towards, bless you, out towards the edge of the area, the outer part of the area. And that's my radius for that cross-sectional slice if I was to actually draw him. That would be the radius for that slice. And so if I need to plug radius into my area formula, I'm going to do top minus bottom. Who's on top of that radius, cool kids? Yeah, my function, 8 minus x to the 3 halves, right? So I'm going to plug that in for my top, and what's on the bottom? bottom I have y equals 0. Question, if something is revolving around an axis, do I really have to worry about the minus? Nope, because if you minus 0, it just ends up going away. Some of you then, since we haven't really seen much else, yes, plug it to your calculator, and our final answer is? That's what I was thinking. Is it E? You guys plugged in, charge and double check?
It's E.
Perfect. Some of you might be like, oh, it's always minus 0, and the answer is no. So we have to get to harder problems where you see it's not always equal to 0. We saw one at the very, very, very end of yesterday. It was around y equals -1. But instead of going to that illustration, which I could, which you already saw yesterday, it might be smarter, it might be wiser for us just to go find new problems and figure out what do you do if it's not around an axis. So let's go find somebody not around an axis.
That's 3.
Are you sure? It says around the y-axis.
Yeah, but it's like off.
Not flush again.
Ooh, not flush again. Okay, so we're going to do a washer first. All right, fine. We'll do a washer first. You guys see the revolution going on in number 3? Question, is this a calculator or a non-calculator looking at those answers? Non-calculator. They have pies in there. They didn't use a calculator. Aw, stinky. Okay. And it's great phrase. Yeah. Okay, so I have y equals x squared. Those are some of the things you guys say. Okay. Anyway. Just kidding, love you all. 1 and a 2 and a 3 and a 4. Yes, wasn't kidding, I do this stuff. Sometimes you frustrate. Not you specifically, students collectively. Lots of I frustrate you. Need for grace. Question, why did I just put little dots just randomly and didn't let my parabola keep going? Wait, hold on. Some of you might make that same mistake. That's not x equals 4. What is that? Those are tick marks on the y-axis. So hold on. What tick marks was I supposed to do for x equals 4? Ah, the side. 1 and a 2 and a 3 and a 4. Yeah. Because I was doing tick marks on the y, but it says x equals 4, so I need to do tick marks on the x. My units are off, aren't they? 4, what do I need? 16? We'll have these go by 4s. There's 4 and 8 and 12 and 16. So I'm thinking about the line x equals 4, which is going to hit here. Does that make sense? I was doing the horizontal line when x equals 4 is a vertical line. Okay, so now I have the right region. I can keep on drawing my parabola all I want, but here's the long story short. They just say x squared, x equals 4 on the x-axis. If I use those 3 things as my boundaries, shouldn't I get this as my area? Check it. Do I have x squared as one boundary? And the answer is yes. Do I have x equals 4 as another boundary? And the answer is yes. And do I have the x-axis as the last boundary? And the answer is yes. Could I shade? Could I shade here and still have the right boundaries? No. Because I would have x squared and I would have y equals 16 and I would have the y-axis. This would be a different region. When they tell you these clues, it's for a very specific placement, okay? Well, because you have to look at these 3 clues. You have to think about, okay, hold on, I will trace y equals x squared and say, okay, that's this guy. I will trace x equals 4 and you're like, that's that guy. I will trace the x-axis that closes in an area. Does that make sense? Mm-hmm. Good, that closes in an area. Kiddos, hold on. What is it revolving around? Why did everybody say this is a washer? It's revolving about the y-axis. Ooh, the y-axis. Hold on. Give depth. Is that dx or dy? That's a vertical depth, right? So vertical would be dy. So we need to go ahead and set up a volume formula. v is equal to, I need some y bounds, and I need a pi r squared, that's right minus left with a dy. Okay, right minus left, wait a minute. Why do I have to say no, it's not a disk and erase all that fast? Is it flush against the axis of revolution? No, it touches in one little baby point, but look at all this hollow space. So, use my hint for big R and little r. Always start from the axis of revolution, some arbitrary point, and go as far out towards the area as you can before it ends. You guys see that's the outermost part in that line? That's going to be my big R. Just to show a distinction, I'm going to put little r a little bit removed. Start at the axis, go out until you start hitting the area. So do you see I have the two boundaries of the area as I go right to left? The outer boundary and the inner boundary. This one's going to be for the whole thing. This one's going to be for the hollow. I need to go ahead and plug into my formula. I need pi times big R squared minus pi times, let's see, little r squared with a dy. Has anybody figured out my y bounds yet?
0 and 16.
Yeah, good. How low does it go? Y equals 0. How high does it go? Y equals 16. So I have 0 and I have 16.
Did you say it was okay that we could plot the pi?
Yeah, I'm going to actually do that next. Just remember, pi is the little guy. You got to always be looking out for him. People want to leave him out. That's a life lesson too. Anyway, pull out the poor little guy people are trying to leave out. Pull out the pi. I have my integral 0 to 16. And I need a big R squared and a little r squared. We'll find him right after I answer a question. Keep him.
How do you use this, Steve?
Oh, because they said x equals 4. And so you could go ahead and plug in and say, what is f of 4? What is y of 4? That's how I figured it out. Sorry, I did it really fast at the beginning. So you know the point is 416. I don't want the x, I want the y. Okay, the pi is officially pulled out from both terms, so that's good. Big R squared. What's the right of the big R, guys? X equals 4, right? So I have x equals 4. What's the left of the big R? Careful, not x squared. Doesn't it hit right here? Yeah. And this line is x equals 0. So x equals 4 defines this line. X equals 0 defines this line. So I'm just going to do 4 minus 0 squared. This is where it gets a little confusing, and some of you might have gotten confused right around here last night. So x equals 0 is that boundary, x equals 4 is the other boundary. So I have my, there we go, 4 minus 0 quantity squared minus, now it's time for little r. What's the right of little r? There you go. But the problem is, question, do I want to put an x squared in my nice little dy formula? So I have to solve for x, so then x is equal to, why am I going to say just the positive root y, not plus or minus? Good, we're on the right, we're on the positive side, so I need positive root y minus, who's on the left of this guy? Good, x equals 0 again. So we end up with v is equal to pi times the integral from 0 to 16 of 4 squared is 16 minus root y squared is y. Well, that's not too bad. No wonder it's by hand. You got a little pi, don't leave him out. Times 16y minus 1/2 y squared. Evaluating on the interval 0 to 16. That's kind of gross. But maybe some of you know 16 times 16. What's 16 times 16? 256. So we have pi times 256. Maybe just a few of you would have to be like, ew, gross. The AP might expect me to do 2-column multiplication. Well, if worst comes to worst, you do that multiplication, lazy bums. Get this problem right? You guys agree it's 256? And then we go ahead and subtract 16 squared, 256, cut in half. 128. If you wanted to be really lazy, I guess you could have factored out a y and then plugged in. Anyway. Minus 0 is just 0, and so we end up with 128 pi. Does that match? And the answer is dun 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 dun. How we doing? Kind of hanging in there? Some are harder than others. Some of you are moving on ahead. I don't know. The question, number 4, you don't even have to solve. I'm just trying to find somebody that's not around an axis. Let's not do number 4. Let's go find somebody that's not around an axis.
6.
Yeah, this was going to be another cross-section perpendicular to the x-axis, but a few of you guys have said, hey, go look at number 6.
Seems like
Revolved about, ooh.
It's all in X's.
Ooh.
And there's a 2 pot.
Ooh, oh. Pause. This is not an AB question. This is a CalcAB question. Any of you guys, in your spare time, just want to learn more calculus, go look at the shell method. The one that you're supposed to skip in the CalcAB and Patrick J and see if you're trying to get more learning done. Keep going. I like number 7. Why? Not for letter A, but for letter B. See him? About the line y equals -1? All right, fine. We'll use number 7 to help us out. Maybe we'll go find another one too in a second. Let's start with number 7. What do you guys want me to do? Skip A and say, it's easy? Or no, we have to draw a picture anyway. Let's not skip A. Kiddos, why did they not give you a picture? This is mean.
it's a calculator.
Oh, it's a calculator problem. Well, that's nice. But also, it's also 2 basic graphs. One just has, on the inside, horizontal flip. Long story short, you end up with little dude going like this, and little dude going like this, approximately. What are they talking about if they say the area bounded by those 2 little dudes? Let me make this a little bit more easy for us to see. That's okay. What's the region bounded by these 2 functions in the y-axis? You see it? You gotta take one, you gotta take the other, and you gotta take the third. Does it close in an area? And the answer is yes. One more time, if you're like, how do you know what's a shape? You gotta take the square root of x, which they give you. You gotta take the e to the -x, which they give you, and you gotta take the y-axis and say what is in between all 3. Does that make sense, guys?
Yeah.
Just think they're the lines you're supposed to color in between, yeah? Okay. So we call this region R. R. How do I find the area of R? What do you guys think this seems to be more like? Top minus bottom or right minus left? We're confused or irritated. If we took right left, who's on the right, who's on the left? Green and red. Well, that's great, that's great, that's great, that's great, that's great, until, wouldn't we have to split up an integral and say 2 different situations? Ew. Let's not do right left. If we can avoid it, let's do what instead? Why? What's on top and on bottom no matter what slice we take? Green and blue. Let's do top bottom. Remember in that one homework you guys had to do a top bottom and a right left? You could just write one integral. Life is so much easier. So top minus bottom, is that a dx or a dy?
Yeah.
Dx. So r is going to equal the integral. You want to write it out. It's going to be top minus bottom. Dx. What are my bounds? How do you know that for sure? For sure. You can graph it and you can find the intersection, and is it for sure the intersection's that one?
Should be, right? I don't think it is.
I don't
The
think so, because the square root
intersection
of 1 is
at-
1 and e to the negative 1 is 1 over 2.71828.
The intersection's 0.4263.
Ah, that's a decimal, kiddos. Hold on. Do you think that decimal is going to be important for the whole problem?
Yes.
Yes. So what are we going to do in our nifty difty graphing calculator to help us out? We're going to stow it. Ooh, not in sequence mode. That's not a good idea. Let's go back to plain old function mode. Real quick, I know, I'm probably beating a dead horse because you guys are like, shh, we know how to do this. Just in case, exactly. E to the, is that ln? Yeah, that's ln. To the x, nope, negative x. I'm going to do a zoom standard just because I have no idea what my window looks like. Ugh. It's not super pretty. If you guys really want to, I suppose you could zoom in and say, what's going on? But either way, what is it super important for us to find? That guy. Tell me what to do. Someone, clearly, succinctly, loudly, go.
Second phrase.
Intersect. Enter.
Why? Because we only have 2 curves anyway.
Okay.
Now, tell me exactly what to do. If we do it in the wrong order, we're going to get messed up. Oh.
Alright, now we have 0.42630375.
Write it down and then rewrite it 5 times during the problem.
Yes.
No. Second, mode. From the intersection, being on the screen, not touching anything else. Second, mode, and say stow. Why? Because if you quit from having found an intersection or a 0 or a max or a min, it will keep it in the memory for just a moment for you to go ahead and say, I need to make him a letter A. Got it. See? And what are you going to do over here? You're going to say something to the effect of, I'm trying to figure out where to put this guy. And this is something that is a great technique to use in an FRQ. You can say something like square root of x equals e to the negative x at x equals 0.42630 ... equals a. And what can I do with that a for the rest of this FRQ? And they have to understand. They will understand. Use it. So, Charlie, we're right, 0, but where am I going to end? At a. Does that make sense? Assign it a variable, and then you can use that variable in your calculator. You can stow it and use it the whole time. And you can just write a and not have to worry about rounding, compounding, error, and all that jazz and getting things wrong when you shouldn't. So what are you going to do in your calculator when you need to find this problem? Well, first of all, hold on, sorry. Who's top, who's bottom?
Third and top. Right?
Nope.
No.
This guy's on top, right? This guy's on bottom.
Sorry.
Right.
You're good. So e to the negative x minus square root of x. Now technically, if you did it the wrong way, couldn't you get a negative answer and say, no, you're positive and put a little absolute value there? Yes. Since we graphed it, aren't we super cool? We can go to our calculator and say, haha, we can use y-bars. Since we have a shortcut, we can actually go find function integrate real fast to make things really nice. We can use our 0. We can use our stored alpha a. We can use our, who did I graph first? I'm guessing I graphed square root of x first.
Yeah, you can.
Okay, good. So I can do alpha and I should go do my y2. Oops, I have to scroll down, sorry. Okay, just wait to do it. Y2 minus, then I have to go find my y1. Go plug in my dx and say, I don't need to show any work on this paper. They know what I'm doing using my calculator. And final answer is point. Wait, hi! No. This is just area. This is just area between curves. No pi. Just top minus bottom. Dun. Okay, how do we do? Okay. How are we doing on our calculators? Okay. Alan.
Are we really allowed to really just write
Yes,
letter A?
please. To be honest, in their answer key, they have done that as well. They might have named it P or Q or S or whatever letter they randomly decide to use. I don't even know when or how they choose. You can just always make it alpha A. And if there's 2 different intersection points, make one A, make one B. But You have to make some sort of statement as to the decimal and what you're calling him at the beginning, and then you can use it the whole time down. Is that cool? Makes life a lot easier, and you can use that little A in your calculator too, as long as you stow it away. Okay. What is going on in letter B? For sake of illustration, real fast, I'm going to quickly graph it again. You don't necessarily have to, but for sake of illustration, real fast, I'm going to zoom in, quite literally, and graph it again. Where are we revolving this buddy around? Now, where is -1? Above or below this region? I zoomed in case you're wondering. Isn't it below? It's not an axis? No. But what am I doing around that line, y equals -1? I'm still revolving. I'm not revolving around the axis, I'm revolving around somebody else, but that's okay, we're going to do the exact same procedure. Now that I have my situation, can I zoom in on just this guy? Kiddos, what's my depth? If I give this cylindrical depth, what am I going to have, dx or dy? It's horizontal, right? Are we okay on this? Okay. Question, is the area shaded flush against the line y equals -1, the axis of revolution? And the answer is definitely not. What is my hint for finding big R, little r? Start from the axis, some arbitrary place, and extend where? To the highest that you can go while still touching the area we're supposed to be using. To the outermost. This is for the whole thing. Can we use 0 to A again because we're cool like that and we know our x bounds already? Sweet. Yeah.
Since it's below, where we're trying to find the area, what would be the difference between finding it the way we are now and if we just found it was y equals 0? Would it not change it?
Just wait. Instead of minusing 0, you're going to minus -1 and you're going to change the value. Just think of it this way. Our big R, this guy, right? What is he going to equal? We can do them off to the side if you want. Whose big R is top? E to the -x. Whose big R is bottom? Y equals -1. Whereas before, if we were just to use y equals 0, it'd be -0.
Yeah, I understand that.
Does that make sense? So it's going to change the value. Now, is it going to change it by tons and bunches? No, but it is enough to make it wrong. Does that make sense? Now for our little r. What's my clue or what's my hint for little r? Always start from the axis. Always start from the axis. And extend where? To the edge of the nearest boundary. The edge of the hollow. If you guys are cool, you might see this would look something like a crater, right? Because if you were to rotate, you kind of have like a mountain, but then it gets cut off, and then you have like this big old hollow thing in between. Not even a crater, it's like a crater that goes all the way down to the ground. But anyway. Maybe two mountains that are friends. Anyway. What's the top of little r? Who's that? Yeah, the square root of x. Minus, what's the bottom? Y equals -1. Right? So what are we going to do over here when we go to plug all this jazz in? V is equal to, Bridget, we can pull out that pi, yeah? So we pull out that pi. Don't forget about him, but we pull him out. Big R squared, well we know who he is. He's e to the -x plus 1 squared minus little r squared. Square root of x minus -1 is plus 1. Careful, the square root ends with the x. squared. All of that is inside an integral of dx. And since we're allowed to use our calculators, what are we going to do? We're going to chug that puppy, right? So we go back to our, always way up there.
Wait, why do you use +1, not -1?
Because minus a negative 1 means plus. Minus a negative 1 means plus.
Wait, why is it minus a number?
Because it's top minus bottom. Great brain. Top minus bottom. Bottom is y equals negative 1. So minus negative 1 would be plus 1.
Okay.
You guys plug in and chug in? What do you need to not forget? So you're going to put them in first so that you don't forget the poor little guy. Put in that pi. Then go ahead and put in that function integrate. Then we can go from, what are we doing, 0 to a? We haven't changed to a, right? Isn't he still the guy that we stowed a second ago? Josh, right there. Brendan is at the end of class. Yeah. Have it. Get rid of that a and let's put him up here. Face me. Alpha a. Then can't we do a parenthesis and can't we say, let's see, e to the negative x, that was our y2, right? Careful, make sure you got it. In the sense of the order of which one's which. Maybe you could even, like in your paper, put y2 equals e to the negative x, y1 equals square root of x to help you remember. But we have e to the negative x plus 1, all raised to the second power, minus, watch your parentheses. We have our square root of x, which should have been our y1, plus 1, minus a negative 1, all quantities squared. Oh yeah, nope, it's not going to like it. Don't forget your dx. Ready, set, go. It's thinking, it's thinking, it's thinking. Got it. And why is mine good? Because I put a pi in front. If you didn't put a pi in front, are you good yet? No. Don't forget to put your pi. So what's different when you're revolving around somebody other than an axis? You have different bottoms, or sometimes you have different tops. You have different bottoms, or sometimes different tops. Now, kiddos, letter C is going to be a cross-sectional area. Ooh, a cross-sectional volume, semicircle. Top minus bottom is going to be a diameter. Cut it in half. We have examples like that in our notes. Now, pause. I need to go find this particular problem that gets particularly tricky. What have we done so far? Mostly odds? Well, I had to find this. We did a lot of odds. Okay. Let's go find if we can see I don't like that one. I don't like that one. I mean, I do. These are all good. It's just, I don't want it. How about this one? Ooh! I like number 10. I like number 10. P.S. Guess what? He's a non-calculator. I like number 10, letter B, for what I'm trying to illustrate. I like number 10, letter B, for what I'm trying to illustrate. Okay, kiddos, do you see y equals 2 square root of x? Okay, good. What else do we have up here? The horizontal line, y equals 6. See it? And we have an area between, true? It says, and the what? The y-axis? Good. And the y-axis. Okay. We could find the area. That's all well and good. Just real quick, would you guys do top, bottom, or right, left for area? Okay. To find top, bottom, question, what are going to be? Ooh, hey, look what they gave for us, because it's a non-calculator problem. What's my second x for my x bound? 9. What's my first one? 0. Okay. What is letter B having us do with this region? Write but not evaluate, yeah, blah, blah, blah. Volume of the solid generated, blah, blah, blah. When R is rotated around who or what? 7? What?
Yeah.
That's above. That's right, that's above. Draw the line y equals 7. Wouldn't that be up here? Who are we revolving around? Him. See why I want to look at this one? The axis of revolution is above the area. And I say, no big deal. Question. If I put depth, is that horizontal or vertical? Horizontal. So question, dx or dy? Oh, it goes, depth goes that way, right? Depth goes horizontally, so that's a dx. Question, what is my clue when I say big R? Because this is a washer, right? Do you guys see how it's not flush against? Okay, it's not flush against, there's a space in between. What is my clue when I say make big R? Start at the axis and extend to the outermost of the area. It's down, I don't care. Extend to the outermost of the area. It's weird, but aren't we following the same steps? Yeah. It's backwards, but it's right. Start at the axis for little r. Extend to the outermost of the hollow. So question, what would big R equal? Top is 7 minus bottom is 2 square root of x. It looks weird, but guys, our exact same system, our procedure works. Top of little r, 7 minus bottom of little r, y equals 6. Awkward, but true. Oh, hey, that'd just be a little baby cylinder with a, yeah, you're right, just be a little baby cylinder with a, okay. Pause. Could you plug in? Yes. Kiddos, guess what? Finish homework 6-2 for Monday. This AP packet is your review. This AP packet is your review. So you can keep working on it this weekend. We can talk about questions on the homework in the AP packet on Monday. We can have another workday. We can review for Tuesday. Sound good? Bye, cool kids. Ella and Brendan, try to figure out life. If it doesn't work, you're going to owe me cash on Monday. But talk to you. Perfect.